Okay, so for today we are going to discuss another technique for integration. All right, so for the learning outcome, you can see that we are going to learn how to integrate a fraction, all right, that with a certain pattern one. So the certain pattern that you can see here is f prime x over fx pattern. Usually I will tell my student that, okay, when you want to apply this technique, the very first thing you look at is whether do you have a fraction or not. All right, so if you have a fraction, so you might able to use this method. Might, not necessarily 100%, but you have to check the pattern yourself. All right, so generally it will happen on f prime x over fx pattern, which is a fraction. So as an example here, you need to know how to integrate like x over x squared plus 1 or how to integrate tangent x. So all these are fraction actually. Tangent x, if you look at it in detail, it is actually a fraction also, which is sine x over cos x. Okay, so the main technique that we are going to learn today is based on fraction, but the fraction got a certain pattern, which is f prime x over fx. All right, and then after that, we are going to apply this technique into a more complicated example, like how are we going to integrate partial fractions? Because this pattern involves fractions, right? So it also might we might include this also in the partial fractions question, how to integrate a partial fractions. And after that also you need to know also how to do the definite integral for all these patterns. Okay. All right, so this is what you need to learn for maybe today's video or the next video. Okay, so first of all, let's talk about the f prime x over fx pattern. So generally, this concept and the integration technique comes from the differentiation idea, where when we want to do the differentiation for log fx last time in chapter 4. All right, so when you want to differentiate log fx, you bring the fx down, become the denominator, and after that you differentiate the fx, become f prime x on top. And that's why you have f prime x over fx pattern. So now we are going to do it the other way around. So when you do the differentiation for log fx, all right, so the answer that you get is f prime x over fx. Sorry, so maybe I write it in this pattern will be better. Okay, so I get f prime x over fx pattern. All right, so this process, and then I think I told you before also, right? The opposite direction of a differentiation is integration. That means if for today I want to do the integration for f prime x over fx, then the answer that I get should be log fx. All right, so this is the basic idea on how to integrate the f prime x over fx pattern. Okay, so you can see the formula here. If I want to do the integration for f prime x over fx, you'll get ln modulus fx plus k. Please take note on the ln here, the modulus here. Okay, because all the value inside the ln should be a positive value. Any negative value in the ln will be undefined. All right, so you will see that there's a modulus here, modulus sign here. Okay, all right. So before I let you all try the example for him in our notes, so I will want to discuss a few examples with you here. Okay, so let us try some basic example first. Okay, so the first one, if I want to integrate 2x divided by x squared plus 1. Okay, so this is a fraction. If you look at it now, maybe you'll think of, oh, last time you never learned how to integrate this before. Okay, then you can check and see what patterns it belongs to. This is a fraction, right? Okay, so usually when you want to check a pattern, you can let the fx equals to the denominator, which is x squared plus 1. All right, and then you double check. If you want to do the differentiation for x squared plus 1, what do you get? So differentiate x squared, you have 2x, right? Differentiate the 1, you will get a 0. So you should have a fx, you will have a 2x as your f prime x. And therefore, very obvious, and if you look at the pattern here, you will see that the expression on top is your f prime x. Therefore, this whole fraction is f prime x over fx pattern. And therefore, when you want to write the answer after the integration, it should be ln ignore the thing on top, you just make it as ln fx. So fx is x squared plus 1 in this case, then plus c or plus k. So you can see that the step is very straightforward, but in between, before you decide the answer, you need to double check the pattern of the question first. All right, so this question itself, very obvious, it belongs to f prime x over fx pattern. Can see that? Okay. All right. So there's no hint for you in exam. You will need to check all this by yourself. All right. So for this chapter, you need to do a lot of practice so that you can identify the correct pattern with the correct method. Okay. So let's try example 2. All right. So maybe we can discuss about this. Okay. So let's say I'm having 3e3x divided by e3x minus 2. Okay, so again, if you look at this question itself, it is a fraction, and then it looks like quite complicated. So maybe I can check and see. For the denominator, I let it become fx. So fx is e power 3x minus 2. All right, so if I want to do the differentiation for e power 3x minus 2, so when you want to differentiate e power 3x, you get back the original thing, and then you differentiate the power. Differentiate 3x, you get a 3, right? So you have a 3 here. So which means that if you double check on the numerator in your question, so 3e3x is your f prime x. All right, so the bottom is fx, on the top is f prime x. Therefore, this question belongs to f prime x over fx pattern. Therefore, when you want to get an answer for the integration, it will be ln fx. So I should fx is e3x minus 2, then the whole thing plus c. All right, so I hope that you understand the idea here. So how can I get the ln fx? It is because of the differentiation technique that we learned before. All right, so before you want to apply this technique, you have to make sure that you're having the f prime x over fx pattern. Okay, all right, so maybe we can discuss another example so that you understand it better. So we not only apply all this in the algebra, you can also apply in trigo. So as an example that we learn before, maybe I try the cotangent x. All right, so cotangent x, it doesn't look like a fraction, but you can try to apply the identity for the cotangent because you never learned how to integrate cotangent before, right? Okay, so cotangent is actually cos x over sine x. All right, so you can see that cos x over sine x, which means it is still a fraction, right? Okay, so we never learned how to integrate this kind of fraction before, so maybe you can check and see whether it belongs to fx over f prime x over fx pattern or not. So I will let the denominator as sine x. Okay, so what do you get if you want to differentiate sine x? So when you want to differentiate sine x, you will get differentiate sine, you get a cos, right? Cos x. Therefore, you will see that this term on top is actually your f prime fx. So this question itself belongs to f prime x over fx pattern. So to get the answer for this integration, you can straight away bring it as ln fx. So what is ln fx? Ln sine x plus c. Okay, so these are a few examples to show you how we apply this f prime x over fx technique, okay, to get the answer for ln fx. All right, so I hope that you understand the idea now. Okay, then let us continue to discuss a few more examples, which is a bit more complicated. All right, so I can tell you, right, not all the while that the question involved in the exam, they will give you exactly the f prime x over fx pattern, like what I show you here. Okay, so sometimes now they might give you something like this. Okay, so as an example, maybe I want to integrate x squared divided by x power 3 minus 4. Okay, so maybe when you look at this question itself, you also feel like, okay, you want to check whether it belongs to f prime x over fx pattern or not. All right, so this is fx. So fx is x power 3 minus 4. Then you check about the f prime x. Okay, so if you check about the f prime x, what do you get? So f prime x should be 3x squared, right? Differentiate x power 3, you should have 3x squared. Minus 4, you get a 0. So on top, you should have a 3x squared. Okay, but too bad now you have only x squared here. Alright, so can you do the integration for this question? So you still can do the integration for this question because you see x squared and 3x squared, they are very similar. Okay, very close to each other. So you can still do the integration by using the same technique, just that you need to do an extra adjustment here. Okay, so you see here, I just copy the original question here. Okay, so to make this question become f prime x over fx pattern, you need to do some adjustment. So what is the adjustment that you should do? You should try to make the top part here as 3x squared, right? So that the 3x squared is exactly the f prime x. Correct? Because x squared is not f prime x now. So you need to put in a 3. So when you put in a 3, it becomes 3x squared. So the top part here will become f prime x. Okay, so to make this whole expression balance, when you multiply a 3 inside your integration, outside you should divide it by 3 as well, so that the 3 and 3, after you cancel off, they are still the same expression. So this is the adjustment, extra adjustment that I'm trying to do, okay, to make my expression become f prime x over fx. Okay, so I hope that you can see this. All right. Okay, so after I do the adjustment already, so this question itself definitely belongs to f prime x over fx pattern. Therefore, again, you can still apply the same technique that I showed you before. Okay, so what do I get now? The 1 over 3 you just copy because you do the adjustment just now, right? So the 1 over 3 you just copy. You focus on the f prime x over fx pattern here. So after you do the integration, right, you should have ln fx. So what is the fx here? X power 3 minus 4. And then the whole thing plus c. So can see that or not? So you can see that for this part now, the integration, I'm still applying the same technique. Just that before I do this integration technique, right, I will need to do some adjustment to make it become the f prime x over fx pattern before I can apply the technique. Understand what I say or not? Okay, so this is another type of example that you can still apply the same technique, but you need to do some adjustment. All the 3 examples here, no need to do any adjustment, right? It is exactly the f prime x over fx pattern already. But for this one, you need to do some adjustment, okay, before you can apply the formula or technique. Okay, so maybe you can try another example here. So let's say we try tangent x. Okay, so again, as what I said just now, tangent x is not it doesn't look like fraction, right? Okay, maybe I make the question slightly more complicated lah. Maybe I make it as tangent 2x. Okay, right. So if I'm having tangent 2x, okay, and then I will want to make it become sine 2x divided by cos 2x, so that it looks like a fraction. Okay, so tangent means sine of cos. Okay, so now let's double check and see. Okay, so my denominator will be fx. So fx is equals to cos 2x. Okay, when you want to do the differentiation for cos 2x, what do you get? Differentiate cos, you have negative sign. Alright, and then after that you have to differentiate the thing inside the angle. So differentiate 2x, you get a 2. And therefore you should have negative 2 sine 2x. Okay, so for those who already forget how to do the differentiation, please make sure that you go back and do some revision on chapter 4 again for the differentiation. It might need some time for you to recall back, alright? Okay, so this is f prime x. Okay, then now, if you look at the numerator on top, you have sine 2x only, but you need negative 2 sine 2x, right? So therefore, what can you do here? So you can do some adjustment before you want to do the integration. So this is the original question of sine 2x divided by cos 2x dx. So to make sure that I will get the f prime x on top, become f prime x on top, right? Negative 2 sine 2x, exactly the same, okay? Then outside, to make the expression balance, you need to divide. Okay, so inside you multiply negative 2, outside you divide by negative 2. So you are having the adjustment like this. Okay, All right. And after that, since you are having the f prime x over fx pattern exactly already, so what can you do now is you can apply the technique. Okay, so for the adjustment part, you just copy it down. So you're having negative 1 over 2. Okay, then now I want to focus on this integration. So f prime x over fx, when you integrate, you are having ln cos 2x, then plus c. Okay, you just ignore the whole thing on top lah. You just need to bring up the fx become inside the ln. So ln fx plus c. So this is what I have. Okay, so after you do the adjustment, you can still apply the technique that I showed you just now. Okay, right. So is there any question for now? Hopefully you have the idea how to do the adjustment to make sure that you're having the f prime x over fx pattern, and after that you can continue with the integration. So this is the integration for f prime x over fx pattern. All right, so I hope that from all this example here, you can see that, okay, at least you have some idea how to solve it. All right, but now I want to discuss a few more examples with you. Okay, so let us have a try for this one. So question number 6 maybe. How about this? If let's say I'm having x divided by 2x power 4 plus 1. Okay, so if I want to do this integration, what can I do? So again, first of all, I will ask students, try to double check and see, okay, is it belongs to f prime x over fx pattern or not? So fx is 2x power 4 plus 1. And then for f prime x, what do you have is, after you do the differentiation, you should have 4 times 2, you get an 8, right? So 8x power 3 plus 1, after you do the differentiation, it becomes a 0. Okay, so here, if you double check, you need to have 8x power 3 on the numerator. Okay, but now my numerator is only x. Alright, so according to what we learned just now, to apply this technique, okay, you can do some adjustment if you want. So what is the adjustment that you should do? So to make it become 8x power 3, okay, so you multiply in the 8x squared. So that the whole thing now become 8x power 3. So when you do the adjustment here, outside you also need to do the same adjustment. So you divided it by 1 over 8x squared. Okay, all right. Then after that, if you continue from here, okay, so 1 over 8x squared, you just copy it down. Okay, then you just focus on the integration for this fraction. So since you are having the f prime x over fx pattern now, therefore when you want to apply it, you should have ln 2x power 4 plus 1, then plus c. Okay, so for this example, it looks like very okay, right? Okay, so now I can tell you that for this example, if you apply it in the method that I show you here, this method is a wrong one. Okay, so maybe you will question yourself, you start to question, okay, why is this wrong? Because you are just following the exact method that I showed you just now, right? You do the adjustment, you double check, you do the adjustment, you get f prime x over fx, and then you apply the technique. But for this particular example, when you apply it here, it is wrong. Okay, so where is the mistake? Where's the mistake? All right, so now I want you to have a look for all the adjustment questions just now. Okay, so please take note, when you want to apply the adjustment and before you can integrate it, right? Okay, so now let's have a look for all these adjustments here that I showed you just now. Okay, maybe I need to cancel off this one. All right, so have a look for all the adjustments here. All the adjustment that I showed you just now involve only numbers. So you can see that this one I multiply in the 3, outside I divided by 3. There are only numbers involved. Okay, so the same thing happened for the example 5. All right, so for example 5, also the same thing. When you want to do the adjustment, right, you only see the numbers involved. -2 and 2, -2. So are numbers, only purely numbers. All right, and then how about for this example 6? You can see that when I do the adjustment, I put in the variable x, which is wrong. So you have to always take note that when you want to do the adjustment to make it become f prime x over fx pattern, you cannot involve the variable. You cannot involve only any variable. Okay, only numbers can apply into the adjustment, but you cannot multiply in any x, any sign x, or all those things. Only numbers can be accepted to apply this method correctly for the adjustment. Understand what I say or not? Alright, so this is a wrong technique now. But I need to show you here so that you didn't do this kind of mistake in the exam when you want to apply. Okay, alright. So these are some small things that you need to know when you want to apply all the technique that I showed you just now. Okay, alright, so if there's no problem, then I would want you to try out the example 14. Okay, so for example 14 is a mixture of question that you need to do adjustment, and some of the question you don't need to do any adjustment. Alright, so I will give you all the answer here first. Okay, so part A is this one. Alright, and then part B. Part C. And then D. E. And F. Okay, so all these are the answer for this example 14. Alright, so you can have a try. Okay, but I think I will want to discuss two examples with you here. Of course, you can try it first. Then if you realize that you cannot get the answer, then only you look at the explanation here. So you can pause the video for now if you want. Okay, so I will want to discuss example D and also example E with all of you. Alright, so let me discuss example D first. Okay, so when I want to integrate this example, okay, alright, so if I want to do the example here, so this one it will be fx, right? So fx is 2 plus e negative 2x. So when you want to do any, when you want to do the differentiation for the denominator, differentiate 2 you get a 0, differentiate e power negative 2x, you get negative 2e negative 2x. Right, so you will see that on top you only have a 1. So you cannot do the adjustment also, because if you want to do the adjustment, like you have to multiply in the negative 2e negative 2x. The x already is a variable, so you cannot multiply in the variable to make the adjustment. Alright, so if you look at this, then generally you cannot apply the f prime x over fx pattern. Okay, but this is a question that is quite tricky because you need to do the adjustment also by using some other method. Okay, so before I show you the adjustment, okay, I cannot do anything here, but the e negative 2x, I can change it become 1 divided by e 2x. Okay, so the 1 over e 2x, to me, right, it is something that is very troublesome. So I multiply it with e 2x to make the fraction disappear. So if you multiply something at the denominator, on top also, you also need to multiply the same thing so that the whole expression is still balanced. Okay, so when you want to do the adjustment, when you multiply e to x already, then you double check and see you're having 2e to x plus 1. Okay, so at this stage only now, you try to check your fraction again. So your fx is what? Fx is 2e to x plus 1. So when you want to do the differentiation for fx, your f prime x should be 4e to x. Right, so you'll see that, okay, you have e to x on top, you let off a 4. Therefore, to apply the method that I showed you just now, what can you do here is you will try to do some adjustment. So to do the adjustment, you just copy back the fraction that you have. Okay, so I'm very clear that I need to multiply in a 4. So that this expression, the fraction itself, become f prime x over fx. So the outside one, you need to divide it by 4. Okay. All right. So after this adjustment, you can see very clearly that you are having 1 over 4 f prime x over fx. So when you do the integration, you're having 1 over 4 ln 2e 2x plus 1, then plus c. So this is the answer for part number D. Okay, so I understand that it is a bit tricky because the way that they show you is quite tricky, not a very straightforward way. But of course, to show you the discussion here, this question here is to let you have the idea that the question can be asked something like this in this pattern. Okay, so this is what we have for part D. All right, then another tricky question is about part E. Okay, so part E, they want you to do the integration for 1 over x ln x. Okay, so when you double check and see, if let's say you let the function fx equals to x ln x, when you want to do the differentiation, right, you need to apply the product rule. And then when you apply the product rule, definitely you won't get a 1 on top. All right, you can try it on your own. So definitely, I don't want to show you anymore, but you can see that your f prime x should be quite complicated. It shouldn't be only a 1. All right, so if you want to make it become f prime x over fx pattern, you need to multiply in the something like a variable, which is not valid, right? Not a correct method. Okay, so what can you do? So again, for this fraction, you might need to change the pattern a little bit also. Okay, so before I start with it, I just want to recall back some small concept here, small idea here. Okay, if let's say I'm having 1 over x divided by 3, so how can you do it? So 1 over x divided by 3, last time when you learned, it should be 1 over x divided by 3, right? Okay, so 1 over x divided by 3, that means it is 1 over x multiplied with 1 over 3, and therefore you can put it as 1 over 3x. So have a look for this one and have a look for this one. So that means when you're having 1 over 3x, right, you can rewrite it become 1 over x divided by 3. Okay, or you can write it become 1 over 3 divided by x. You can either pull the 3 up or you can pull the x up. Okay, so the same thing happened here. So 1 over x ln x. So the x is x ln x, you assume that it is a 3. 1 over x3, you can actually make it become 1 over x divided by ln x. Okay, so again, you can double check the pattern. So what is this? This is fx, which is ln x. And then if you do the differentiation, you will get 1 over x. All right, then after that, from here, integrate f prime x over fx pattern. This is definitely f prime x on top, fx at the bottom. So when you do the integration, straight away apply the formula or the technique. So you're having ln fx. So your fx is ln x. So you will get ln x plus. So this is how you get an answer. So these two examples here, you can see that it is a bit tricky, and the way that you need to do the adjustment, it is slightly different. Okay, all right, but you are not going to multiply in or divided any variable. Understand what I say or not? Okay, so these two example I discussed it with you here so that you have the idea how to do it. Then the other part of this example, they are quite simple and straightforward. Therefore, you can do it on your own. All right. So if you have any idea, you can. You have any question, that you can let me know again. All right. So I will stop here for this video, and in the next video, we are going to discuss more on the more on the application part of this technique. All right.